Hello, Slardabart Fast fans. I'm Kevin Ripa, and this is my Sans 3 Minutes Max. Today we're talking about the simplest computer in the world. The simplest computer in the world? Yes, the simplest computer in the world. The simplest computer in the world is a flashlight. The flashlight is either on or it's off. It is either a 0 or it is a 1. This works great for a flashlight when you only need to control 2 states. But what if you wanted to do more than just cast light? What if you wanted to communicate with someone? You could use various on or off combinations to represent letters, just like Morse code. But one flashlight with 2 states wouldn't be enough. We need more flashlights. Well, with our byte example, this could be 8 flashlights. 8 bits either on or off. That's great for representing letters, and we could turn the flashlights on and off in any combination we need. But what if we only needed a few states most of the time? We would have to juggle 8 flashlights all the time when maybe we are only ever using 4 or less. What we need is more compact ways to represent the light signals so that we don't have to juggle 8 every time. How about we cut them in half? Then we only need to worry about 4 flashlights at a time. Welcome to the Nibble. A nibble is 4 bits. Now let's not get excited about the 1 hex character thing. We'll worry about that in another episode. Also, we're not going to worry about endianness again. We're going to cover that in an episode following the hex character episode. Here then is a nibble. It looks like a byte split into 2 halves only because it is. 4 bits on the left, 4 bits on the right. Each set of 4 bits is called a nibble. Left nibble, right nibble. Let's break it down. The same binary concepts apply here as they did with the bytes, as you can see, except adding the power of or exponent of 2 only applies to each nibble. So the right nibble, 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, and then we hop over to the left nibble and it starts all over again. 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. So now let's do the math. You recall from our byte episode, the 2 to the 0 in exponent math is 1, or whatever the value is in that placeholder. So then we have 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 4 is 0, and then, or 2 to the 4 is, 2 to the 2 is 4, 2 to the 3 is 8, and it starts all over again. 2 to the 0, 1, 2, 4, 8, just like before. But now we've got to convert it all, just like in the byte episode. To convert this to decimal, we take the values above the placeholders that have a 1, add them together. In this case, because there's 1s in every placeholder, total is 15 per side. Per side. Because each nibble gets treated separately. Now you might say, why not 16 and 16? Well, because we didn't count 0. So let's try one without like a normal byte value, just for practice. In the slide here, we only add up the placeholder values to the placeholders that have a 1 in them, and we ignore those with a 0. As a result, we get decimal 5 in the left nibble and 10 in the right nibble. Because the right nibble sum is higher than 9, there's another step, but we'll get into that in the next episode on hexadecimal. So that's it. In the meantime and in between time, that's it. Another episode of 3 Minutes Max.